Okay, in the last class we have discussed one example how you can find the convolution of the two signals in continuous time. I feel that there is a need to discuss some more examples on this because you may find it difficult to understand or more complicated. So I will take one more example here. Suppose you take two signals. One is xt is equal to e raised to power minus 3t ut, and another is h of t is equal to u of t minus 3 minus u of t minus 5. You have to find the convolution of the two signals. Okay, so if you plot them, this is exponential function, decaying function xt. At t is equal to 0 it is 1, so as t extends to infinity it drops to 0. And this function sorry, h of t, this is u of t minus 3 minus u of t minus 5, so it is basically a rectangular pulse between 3 to 5. It is 1, else it is 0. You have to find their convolution. Okay, so again the process is same. You have to fold one signal, then shift, then multiply it, then integrate. Okay, so either you can fold this signal or you can fold this signal. We will take again both the cases. Okay, let us suppose I fold h of tau. Okay, first you have to express these functions in terms of tau. So I take x of tau, which is e raised to power minus 3 tau u tau. The second function is h of tau, which is a pulse between 3 to 5, rectangular pulse with the height of unity. Okay, so I have to find the convolution. Suppose I use this equation x of t minus tau h of tau. In one case, okay, it means I am folding x of tau. So if I fold it, I will get x of minus tau, which will be a function like this. And then when you plot x of t minus tau, now for t greater than 0, of course, it will be shifted to the left. So as a result, when you multiply this function with this function, your product is 0. So y t is simply 0 for t less than 0. Okay, for t greater than 0, this pulse will be shifted to the right. Now in this case you can see that even if you shift it to the right, so when for t less than 3 up to when this pulse will reach at t is equal to 3, the product will remain 0. Okay, it means your second pulse, this is h of x of minus tau, this is fixed between 3 to 5. Now you have to shift this pulse to the right by some time t. So when you shift it by some time t, which is less than 3, you will get a pulse like this. Okay, so if this t is less than 3, the product is again 0 because they are not overlapping. Okay, it means your yt is basically 0 for t less than 0, and it is also 0 between 0 and 3. Now when you reach at t is equal to 3, at that time, since this pulse is fixed, second pulse at t is equal to 3 will become like this. Okay, it will reach here, and for t greater than 3, this will be shifted to the right by some time t, and now this much portion of the two signals will come in the product. It means from 3 up to this time you have to integrate. Okay, and this situation will remain constant till this point will reach at t is equal to 5. Okay, 3 to 5 it is fixed, so this equation will remain constant till you reach here. At that time this is the overlapping region from 3 to 5, and for any time beyond this 3 to 5, if you further shift this pulse beyond this, it will go ahead of 5, but the overlapping region will remain constant between 3 and 5. Okay, so what is the limits of integration? For t less than 0 it is 0, for t between 0 and 3 it is again 0, or you can directly combine them into one, that for t from minus infinity to 3 it is 0. Okay, and between 3 to 5 we have one more limit, that is between 3 to 5, and then second is for t greater than 5. Okay, so between 3 to 5, what will be the limits of integration for this function? It will be from 3, your yt, the lower limit will be 3, it will, because beyond this your h of tau is 0 for t less than 3, so product is 0. And if this is some time t, beyond this your x of t minus tau is 0, so your non-zero values are only within this band, and within this band, since this function is 1, so in the product it will be this curve, the area under this curve. Okay, so it will start from 3 to t. Okay, so this t can be anything between 3 to 5. So we have to integrate from 3 to t. H of tau is 1 into x of t minus tau. So x of t was e raised to power minus 3t ut, so t minus tau will become e raised to power minus 3t minus tau d tau. Okay, so if you integrate it again, e raised to power minus 3t, you can take outside the integration, you will get e raised to power 3 tau divided by 3, limits from 3 to t. So it will become e raised to power minus 3t upon 3 into e raised to power 3t minus e raised to power 9. Okay, or you can multiply them, you will get 1 by 3, the product of this will become 1 minus e raised to power minus 3t into e raised to power 9, or you can write it as 1 by 3 into 1 minus e raised to power, you can take minus 3 as common, you will get t minus 3. Okay, so between 3 to 5, this is my answer. Now at t is equal to 5, you will reach here. This is the situation. And for t greater than 5, what will be the output? For t greater than 5, the limits of integration will be fixed. From 3 to 5 it will again overlap the entire region. So limit will be from 3 to 5. Okay, again h tau is 1, x of t minus tau is e raised to power minus 3 t minus tau and d tau. So you can integrate it simply, e raised to power minus 3t will be outside the integration, and you will get e raised to power 3 tau here. So integration of that will be 1 by 3 e raised to power 3 tau, limits from 3 to 5. So you will get e raised to power minus 3t by 3 into e raised to power 15 minus e raised to power 9. This is between 40 greater than 5. Okay, so these are the two answers. If you shift and fold this function and you keep it as fixed. Now we will take the second situation. So I have two functions, tau, x tau, and the second was h of tau. Now I suppose fold this function and shift it. So when you fold it, it will become h of minus tau. So limits will be from minus 3 to minus 5. Okay. And now when you shift it and multiply with h of tau, you will get x of t minus tau here. Sorry, h it is now h of t minus tau. So when you shift this function to the right, till you shift it by 3, when you shift it by 3, this h will reach here at t is equal to 0. So before that your product is 0 because it is 0 for t less than 0. It means again your yt will be 0 for minus infinity to 3. And when you shift this pulse yt is equal to 3, you have a situation like this. This will come here 0 and it will be at minus 2. Okay, now for t greater than 3, what will happen if you shift it beyond 3? So this pulse will be shifted now to the right by some time t. Okay, so as a result, this will be your region of integration. Okay, it means you have to integrate from 0 to this time. Okay, so your yt for t greater than 3 and less than 5. Okay, your yt will be, limits of integration will be from 0 to this time t, and x of tau h of t minus tau d tau. Now you have to keep in mind one thing, that whether my limit of integration should be from 0 to t or not, because we have started from minus 3. This function was shifted from minus 3, not from t is equal to 0. Okay, like suppose when you shift this function by t is equal to 3, it will come here. You have a situation like this. Suppose this function is now keep fixed. The second function you are shifting, when you shift it by t is equal to 3, it will come here 0, it will become minus 2. Now when you shift it for t greater than 3, it will go ahead. Suppose I shift it by 4. If I shift it by 4, it means this edge which was at minus 3, it will come at 1, and this will be at minus 1. So from 0 to 1, your area is overlapping. Although you are shifting it by 4, it means the limits of integration is not from 0 to t. It should be from 0 to t minus 3, isn't it? If you shift by t is equal to 4, your overlapping isn't from 0 to 1 only, so 0 to t minus 3 only, not 0 to t. If you take 0 to t, it will go from 0 to 4. Okay, so you have to keep this in mind, and then you can simply integrate it 0 to t minus 3. Now x tau is e raised to power minus 3 tau, and h tau in this case is 1. Okay, so if you integrate it, you will get here minus 3 tau minus 1 by 3 limits from 0 to t minus 3. So you'll get minus 1 by 3 e raised to power minus 3, t will be t minus, tau will be t minus 3 minus 1. So you can take it as 1 by 3, 1 minus e raised to power minus 3 t minus 3. So this is the same as we got in the previous case. Okay. Now when you shift it by, so for second limit, that is between 3 to 5, you have this as the output. Now at t is equal to 5, what will be the situation? When you shift this function by 5, this lower leftmost edge will reach t is equal to 0. It means we have one function which was fixed. The second function we are sliding it, and when you reach at t is equal to 5, you have a situation like this. It will go from 0 to 2 at t is equal to 5. And for t greater than 5, now this function will be shifted to the right, and when you shift it further to the right, it will go like this. It means you have the limits of integration will be from this point to this point on. This is the overlapping region. So from this point to this point, you have to integrate. So what will be my limits of integration now in this case? What will be this point? If I am shifting it by t, this should be again t minus 3, like here, upper limit. And what should be the lower limit? Because since this pulse width is 2 units, it means if this is t minus 3, this should be t minus 5, the lower limit. So I should integrate from t minus 5 to t minus 3. X tau is again your e raised to power minus 3 tau. H tau is 1 into d tau. So you again get 1 minus 3 e raised to power minus 3 tau t minus 5 to t minus 3. Okay. So if you solve it, you will get yt is equal to minus 1 by 3 e raised to power minus 3, upper limit is t minus 3, minus e raised to power minus 3, lower limit is t minus 5. So you get 1 minus 1 by 3 e raised to power minus 3t into e raised to power 9 minus e raised to power minus 3t into e raised to power 15. Okay, or you can write it as 1 by 3 e raised to power minus 3t. You can take it as common. You'll get e raised to power 15 minus e raised to power 9. Again the same answer. Okay, so for t between 3 to 5, you have this solution, and for t greater than 5, your answer is this. Okay, so you have seen there is some confusion here. Okay, how you have to choose the limits of integration. Okay, so there is an assignment question for you. You have to find the convolution of the two signals. One signal is xt, which is supposed like this, 0 to 1, it is 1, and the second is h of t, which I take like this, between 0 to 1, it is equal to t. Okay, you have to find the convolution of these two signals. Okay, again you have to fold one signal to the left, shift it, multiply it, integrate it. Before that you have to find the limits of integration. Okay, I hope now you can do it. Like suppose if I fold x of, I have to first write x of tau, then h of tau, then if I fold x of tau, it will become like this, x of minus tau. Now another signal is your fixed, It is between 0 to 1. This is minus 1. Then you have to shift it to the right. So for t less than 0, of course it is 0 because there is no overlapping region. For t greater than 0, this function will be shifted to the right by this. Okay. So as a result, from 0 to t, this much is the time. This is the region of common overlapping region. So it is simply a triangle. You can simply use the area of a triangle to find this integration. Okay. And this will remain fixed till what time? Till t is equal to 1. So at t is equal to 1, these two functions will overlap like this. So this triangle will give the maximum area. And for t greater than 1, here this function will go ahead one function. As a result, you have only this much overlapping region from this time to 1. So this you can find using the area of a trapezium. Okay. And then at t is equal to 2, you have a situation like this. Okay. The lower edge and the upper edge of the two functions, they will coincide. And for t greater than 2, they will be separated. The product is again 0. This is t is equal to 2. This is for, so you have different limits. One is for t less than 0, it is will be 0. Then between 0 to 1, you have one integration. Between 1 to 2, you have another integration. And for t greater than 2, it will be again 0. So you have to find these two values. Sorry, not 2. You have to find 3 values. For t less than 0, for t between 0 to 1, then for 1 to 2. Now at t is equal to 2, you have this situation. Between 0 to 1, if you shift it by 1, you will get reach here. Then 1 to 2, at and for t greater than 2, it will be 0. Yes, this is how you have to find. Okay, so either you can fold it and shift, or you can fold it and shift it. You have to find the answer. So I hope the concept of convolution is now clear to you. We have discussed many cases. Okay, thank you.